Hi, and welcome back. In this lesson, we will be talking about finding the range of a function algebraically. Before we dive into this lesson, there are a few grounding lessons that will help you to conquer this next topic. Going way back, we can recall that a function is a relationship between an input value and an output value. For a mathematical relationship to be a function, each x value can only have one corresponding y value. Previously, when we learned about range, we thought of it as the lowest value subtracted from the highest value. This makes sense for a data set, but it's a little different when we are dealing with the function. The concept of the range of functions is slightly different. When we are talking about the range of a function, we are talking about all values of y that a function can have. We can also think of range as all possible outputs of a function. In contrast, the domain of a function is all possible values that x can take. We can think of domain as all possible inputs of a function. The easiest way to find the range of a function is by graphing. We can simply look at a graph and see what the y values can be. Let's look at the basic quadratic function. This is a basic quadratic. We can see that there are no gaps or holes in this function. There are also no asymptotes. So, just based on looking at the graph of the y equals x squared function, we can see that the range is all positive values, including 0. We know that because the function starts at the origin, where y equals 0, it only goes upwards. Just for kicks, I will tell you that the domain is all real numbers, since the function can be any value on the horizontal x-axis. This is just one way of finding the range of a function. The method we will talk about more is how to find the range algebraically. Using algebra to find the range will be very helpful when we get to more complex types of mathematical functions like rational functions. There are a few steps that we can follow to find the range of a function algebraically. First, we will define the function as y equals. Second, you will express x in terms of y. Third, you will think of all possible values where x equals f of x. This step will require, you will think of all possible values where x equals f of x cannot be defined. This step will require the most amount of thinking, but once you figure out the pattern, it will make the most sense. Last, you'll write the range, excluding the values that y cannot be. These steps will become more clear in the next slide. Let's go. Take a look at this rational function. We'll walk through the steps we talked about earlier. Our first step was to equate the function to y. So set the equation equal to y. We can see that that has already been done for you. Our second step is to solve the equation in terms of x. In this step, you want to be careful about your math process. Pause for a second and try to do this next step on your own. Here's the answer to the second step. Your answer should be y plus 2 over 1 minus y equals x. I've also left the work on the page so you can check to see how I solved it. Next, our third step is to think through all possible y values, where f of x, our function, would not be possible. Pause and try to think about this one. So we know that the bottom part of the fraction, the denominator, cannot be 0. So we know that y cannot equal 1, because in this case, if y equaled 1, 1 minus 1 would equal 0, and then that fraction would not be possible. Besides that, it seems that y can take all other values. So we will now do the fourth step, where we write the range of this function in mathematical terms, incorporating the values that y cannot be. Here is the answer. This is how we write the range of a function. The range of this function is all real numbers except y equals 1. The y equal 1 will function as our horizontal asymptote. Just really quickly, I'm going to show you what a graph of this function would look like. Here, I've plotted the graph of our function. I've also plotted the horizontal asymptote in blue for you, which is y equals 1. We can see that the function in red will never take on the value of y equals 1, which is why we have an asymptote graphed here. Thank you to Desmos for this graph. And thank you for watching this lesson.